AI with James World.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the AI and .NET ecosystems have to offer. And in this episode, if you noticed the new intro here, we have a name change. And for a long time, we've been the Azure and DevOps podcast. And with all the industry changes and the focus of so many guests and so many interviews on the show, we've renamed the podcast slightly. And so this podcast is now the AI DevOps podcast. And I think that is the future of what it means to do a good job when delivering software. And we're always using the new technology. And it's a new way of working. So hence the new name for the show. And you can find us on any of the audio channels as well as the YouTube channel. So I'll get to the guest. Our guest today is James World. He is a technology leader with decades of hands-on engineering experience, enabling enterprises to thrive through modern cloud and AI-driven solutions. And he's spent well over 10 years architecting cloud-native platforms on Microsoft Azure and guiding multiple development teams through complex digital transformations while remaining deeply involved in the code and critical technical decision-making. His background spans financial services and other enterprise environments where reliability and performance and scalability are really non-negotiable. And he's also a Microsoft certified Azure solutions architect expert and a polyglot developer. Has extensive commercial experience, primarily in .NET and C#, applied across distributed systems, event-driven architecture, and modern AI integration patterns. And he's currently focused on driving responsible and effective adoption of generative AI within the enterprise, from engineering productivity and product enhancement to business assisted tooling. He's been involved with AI initiatives, and he's won several AI hackathons where he's helped organizations move from experimentation to meaningful strategic value. He enjoys solving complex problems, enjoys mentoring engineers, sharing practical insights in architectures, modern software development, and AI augmented delivery practices. And he believes technologies really never stop learning and keep moving. And he believes that commitment is what keeps the industry exciting. So, James, welcome to the show. How are you, sir?
Jeffrey, very well. Thanks very much for having me. Really honored to join quite a spectacular alumni of guests that you have on the show. Yeah, pleasure to be here.
Happy to have you. I always like to ask my guests, if you were to, you've been in the software world for so many years, if you were to kind of go back earlier in your days, what was the trigger, or what has been something about custom software that has just really engaged your imagination and kept you in this field without a career change for so long?
And I guess my interest in computers goes back quite a long time. It was shortly before my 7th birthday when my mother got my father a ZX Spectrum for Christmas. Mm. Within about 3 weeks, it was in my room because he was sick of having me in his study all the time. He was actually a doctor by profession, and he'd been interested in using computers to help with his research. And it wasn't too long before I was the desk jockey that was writing the codes to help him with his work. So I was kind of into the idea of delivering value and solutions for business from an incredibly early age. I didn't even realize that you could play games on computers for about the first 3 years of owning a computer. That proved a bit of a distraction for a little while, but I've always been fascinated by solving problems with technology.
Awesome. Yeah, that's actually great. If you can, there's so many things to do on a computer besides games. Well, you've been one of the people in the industry that's not only been keeping up with AI, but really leaning into it and pushing forward. And so you've done this AI hackathons and done various other initiatives. I want to get your commentary to start out with. What, from a adopter curve where you can be figuring out a new technology, it's bleeding edge, to when something's ready to adopt versus something should be in the late majority. What parts of AI do you consider just regular tools in the tool belt right now? And what parts of AI do you consider in the category of we're still trying to figure out how to use it?
I think certainly where my focus is, particularly at the moment, in trying to use it to enhance the SDLC. It's kind of everywhere in all of those places right now, right? It's useful right now. You can use it to accelerate production right now, but it's still, it's changing. Like, forget week to week, it's day to day. I think that we've passed a bit of a break point, probably late last year, around the Opus 4.5 timeframe, where there seemed to be a bit of a turning point into just how good the quality of code was that you're getting out of systems. But it's really interesting because even within my organization, I think there are different opinions on that from developers, and it seems to come from when it is you've been paying attention. If you're not fortunate enough to have the time to be constantly keeping up with it, then you might have looked at it, June of last year, and played around and done some things and not had a great experience and formed an opinion, which is now horrendously out of date. But sometimes it can be hard to shift those early formed opinions. So I think you have to keep experimenting. Where we are today, you can get tremendous value, but I think you have to spend quite a bit of time configuring things, evolving things to work to get that value out of AI, right? Context is a very scarce resource at the moment. So a lot of the process is around informing the AI within that limited window of context that it has to know what it needs to know to get the job done. So you can have a bad experience because you try and one-shot something, even with a very large prompt, and then it doesn't deliver, and you spend a long time trying to unwind what was done or improve what was done, or you end up having to review a ton of stuff to get to the right place. But I think the bleeding edge now, the people that are really getting the most out of this are spending a lot of time to train AI on how to specifically work with the problems that they are trying to get it to solve and the code that they're trying to work with. And the more you tell your tool about the environment that it's operating in, the greater the accuracy, the faster you'll go, the more success that you'll have.
Okay. So because it's so new, we don't have a lot of good studies or industry surveys out there, but we just hear, random reports, random stories, really anecdotal, not to the level of a study. And you hear anecdotes of like the people on the Claude team saying, well, we don't write any code by typing anymore. It's all written by using the tool. And then you have others that say, well, we bought the licenses and they're using it. And now the team's throughput is actually slowed down. So how do you sort out, and how do you actually apply it so that the team does speed up? Because isn't that the point?
Yeah, absolutely. I think it's like anything. If you start to change the way that you work, it's inevitable that at first it's going to slow you down a bit because you have to learn that new way of working. And then you kind of have to work through that hump, and then you'll accelerate and see the benefits. I think I'm certainly in that place now where I no longer really spend a lot of time looking at the code that gets written.
Mm-hmm.
And that's kind of strange, right? Because that has been where we've all been as developers for, in some cases, decades. And now the shift is much more on code specification, right? You hear this phrase, spec-driven development. And this is where it's like informing AI what it is that you want it to do, making sure that it doesn't have to work hard to find that out. And as teams, that means that you need to be disciplined about having an approach that can be shared between the members of your team. So it's very easy, for example, to find a selection of plugins and prompts and skills and agents that will, and keep them local to you, right? How you share those things, it's getting easier, but it's still a real wild west in the tools.
Mm-hmm.
Am I writing an agent file? Am I writing a Claude.md file? Do I create a plugin? Do I use a marketplace? There are all sorts of different strategies for sharing these accelerators that you can put into your tooling. So that's something that I'm spending a lot of time thinking about, is how do we educate developers to navigate their way through well, first of all, I think even make them aware of some of the options and what's available to, but then navigate through all of the choices. What I think doesn't work very well is trying to come up with, these are the things as an entire organization, entire development organization that you should be using, because certainly right now you need to pick and choose. And again, it comes back to that point I was making earlier, that context is limited. So you can't find, 100 awesome tools and put them all into your environment, because it's just going to be too much for the AI to navigate.
Yeah.
It's even the case that as you go through different aspects or different parts of your development workflow, it might be that you want to bring in different tools into play. So I think even down to the repository level, it can make sense to prepare that specific code base to be able to prepare the AI to use specific tools for a particular base. One obvious example might be that your code base works in a particular programming language predominantly. Maybe it's a .NET repository, or it's a Node.js repository. So having the LSP available for that language, which enables AI to understand and traverse definitions in the code without having to grep every single file, right, that's immediately going to save you a whole load of tokens.
And let's make sure we define for the listeners.
That's a language server protocol. So this is what enables IntelliSense to light up in your IDE. Right, so getting that semantic understanding of language. If, for example, you wanted to rename a symbol in a file, right, everywhere a particular variable is used, then without an LSP, that becomes searching through all of the files to look for the instances of that variable, and in fact, maybe missing that the variables that got the same name in many different places actually a different variable, right? You don't get that context. So sure, AI can work through that. Opus is very capable of doing all of that, but it has to read everything to get the context to be able to make that determination.
Yeah.
Whereas if you can go straight to a symbolic rename with a tool, it's much faster and it's more accurate.
So that starts with not all of these operations are purely a language model operation. It's delegating to tooling that's existed for quite a while in the refactoring tools, right?
Yeah. And I think that is a thematic, and we'll probably come back to this from other angles. I think that's thematic of good generative AI usage, is that, generative AI is inherently probabilistic. You'll hear this again and again. This is stochastic model that's trying to predict the next sort of right thing to put. But that comes with risk, right? It's effectively, making a best guess all of the time. But we know that what works every time are deterministic logical processes. And so a lot of what we're doing with AI is like putting layers of defense around the probabilistic piece to try and get some deterministic, predictable results. So, I see that across the spectrum, everywhere from like how we build products that leverage AI to right down to, within an SDLC, if you're creating a skill or a sub-agent in Claude Code, putting in specific bash scripts, which is something that you can do to tell it exactly how to run your tests every time, for example, or how to run your build process, is going to mean that it's not going to falter and guess at that. It's going to accurately run the tests every time. And it's going to do that within, a CLI. And you can do things like then, for example, have an agent which runs that script, pulls back the results of running the test, looks to see if were they all successful. In that case, that's all, your main session, your main context window needs to know everything passed. Or if they failed, just give me the error message, the lines, the things that failed, and then you've got a predictable run. You've got just the information that you need being passed back up to the context, and that's kind of what I mean around customizing your process to optimize the information and tailor how you're using the tools to your specific project.
So go ahead.
Another really good example, one of the ways that you can amp up how effective the agent is at testing whether it's done something correctly when you're developing a web front end, is to give it the Playwright MCP tool. It's one example that can go and drive the website. But what you'll often find if you start with that tool is it will fire up the website. And if it built that website for you and you didn't build it, perhaps even if you did, depending on how familiar you are with this, then navigating that website with Playwright could be a potentially painful experience. If you've got loads of controls, they've all been written with a slightly different style. Maybe you didn't optimize them with the sort of things like the data tags, which can inform a tool like Playwright how to accurately navigate the user interface. So, I've seen that happen where you can spend an entire context window's worth of tokens with the agent just figuring out how to put text in a text box and click a button.
Yeah.
And then, the danger is that you go, that was awful. It's just not ready. Instead of, at the end of that particular test, you can go into the prompt and you can say, you seem to struggle with putting that text in the box and pressing the button. Could you create a markdown file and put some notes in there to explain how you managed to complete the test, but also what changes could we make to the website to make it easier for you to navigate the website in future? And then you're going to get back a set of instructions, a task list, basically, so you should go and improve the design of your website to make it easier to test. And there's this kind of meta layer sort of applies all the way up. Every time you do something in Claude, if you struggle to do it, I should say, obviously, Claude Code happens to be my particular CLI of choice, but others are available, and they're all, depending on which day of the week it is, they're all pretty good.
They're all competing.
Yeah. You can jump back a level at every point. If you struggle, you can say, Claude, can you write this piece of functionality to me? And you get a bad result, and you say, how would you go about designing functionality like this? Or if you're starting a project and you're not sure where to start, have the AI agent interview you to ask you questions. Very common thing that I do if I'm checking out some new piece of technology I've not looked at before is I have an agent. Effectively, it's a big prompt that just describes what it is to do a technology spike, and then it's very generic. Start off, ask me questions to find out what the objective is of this technology spike, and help me formulate a plan to complete the spike.
Mm-hmm.
And then you go through that process, and part of the output of that process might involve creating specific skills or configuring specific MCP tools which are going to be useful in the execution of that spike. So, one thing that we often use is pulling in the documentation for a new technology. Now, there are tools that can help solve that specific problem. I'll call out Context 7 is a good one. There's an MCP that has curated lists of project documentation that you can find.
Tell us the name again.
Context 7.
Okay. Great.
Now you can browse to it in the Claude plugin marketplace. It's promoted there. It's a community-run GitHub repository, which enables. It has an MCP tool which lets you search on a particular technology stack.
Great. We'll put that in
Let's
show
say,
notes.
for example, you wanted to use like Node.js or the latest version of React, right? Those things are moving all the time, and of course, agents at the frontier models are point-in-time snapshots with their knowledge. So they will quite often, if you do a lazy bit of prompting, they'll go and install all the tools and there'll be a couple of versions out of date, or they won't have picked up the latest bug fix. So with a tool like Context 7, you can have the agent will reach out and pick up the very latest documentation to understand how to work with that particular technology.
Okay.
Yeah. Or for example, if you know the link, give it to the agent's memory. Answer that question in your interview. And one of the things that my interview agent will do is create the meaningful entries in the memory system so that it knows to always go and look up and grab that information. Another good example is I like to lay out my .NET solutions in a particular way.
Mm-hmm.
I like the new solution format. I like to always, one of the bad habits I think that the AI has is that it will often create a new project by writing out the project file text directly rather than using the CLI tools. So I have pointers to the CLI documentation. I tell it how to run the LLM-friendly switch in .NET to go and get the schema for the command. So it knows exactly how to call those tools. And I say, always use .NET New to create a new project. Always add it to the solution. Always get packages by using, the NuGet package add commands, so that it's going through the proper process. And that way you avoid getting a load of versions that aren't compatible with each other and aren't the latest up-to-date version that you need. So this is another good example of just building up the right knowledge in the context, so the AI is not having to guess or use outdated information.
Okay. Well, yeah. I want to get your take on how our listeners should apply this. So with any sea change in technology, often a useful approach is to take a new project to apply the new thing. Way back when Agile was considered new, way back when automated deployments or cloud or anything is like, okay, we're building some new code base. Let's pilot this new thing before we try to apply it to our big, hairy legacy system. And so with AI, if someone's starting a relatively new project, what is your favorite way to set up soup to nuts development, AI-driven development for an application? What types of things do you just say, okay, well, before we even start, we're going to put these things in place?
Okay. So I think I've kind of started to describe that a little bit with that sort of interview process. I think that's very helpful for any new project to go through that kind of step, to just create the sort of the basic agent memory file like your Claude.md, and pull in some useful skills to work with your technology. And again, you can ask the agent to help you do this setup. So I'm going to be working with .NET. Create me a skill to facilitate creating .NET artifacts, right? And then you can review what's been done. Always use source control, right? You always want to be watching what the AI is doing. So always get in it. One of the first things that happens, you can again ask the AI to help you. It can do that. Tell it to create a git ignore that's sensible for the project at hand. One of the things that you'll start to do as you get used to this is start to run many sort of agents in parallel. And so another thing that's, as well as being able to track what's been changed, Git will facilitate you being able to create what's called multiple work trees, which are essentially it's multiple branches able to be open across the same repository, typically side by side on your file system, but all sharing the same underlying Git repository. So you haven't got a complete clone of the repo in place. And there's a few other things that work trees do for you that makes it a bit easier to work with multiple copies. And then you can point your agents at different work trees to do their work in parallel. So source control, absolute no-brainer, kind of table stakes. Another thing that's really important, as mentioned, is context efficiency. The performance of an agent noticeably tends to drop off when it's sort of around 60% of the way through its context. Mm-hmm. So that's kind of a warning sign that you need to break down your workflow into small enough chunks that it's going to get the next step done before it runs out of context. So a couple of strategies for doing that. The first is actually to break it down, and we'll talk a little bit about how to do that effectively in a bit. The other thing is to make use of things like sub-agents and forking skills. So these are things that Claude can help you make, or that Copilot can help you make, that have their own context. So going back to that example of running tests, you don't want to run your tests typically in the same context as your main session. If you can have your main agent talk to your sub-agent to run the tests, then even if you're waiting for the result, what you're not doing is filling up the context of your main agent. But to track your context, put it sort of very obviously, you want to use a tool like CC status line is a good one for Claude Code status line. There's a GitHub repository for that. You can run that. It's a very easy setup, and it will allow you to configure the status line that you see at the bottom of the Claude window, and you can put in there a little bar graph which tells you how much context you've used.
Okay.
So that's a great little tip. I always like to have that in place. And then it's really useful to consider putting in place a spec-driven workflow tool. And now there are a number of these around here. I think probably GitHub Spec Kit is the one that has sort of got the most awareness in the community because GitHub put it out there, but there are many others available. But these are all essentially doing the same thing. They are walking you through the process, it's sort of the typical software design process in a sort of a microcosm. So they will help you to initially specify the requirements of your project. So this is like kind of the solution independent. This is what I want the project to be able to solve for, to do. And then we'll walk you through an initial sort of architecture kind of technical design process to take those requirements and build a plan for implementing it. And then ultimately producing a task list, which is almost always a markdown with empty angle brackets in them. First, I'm going to do this and then this. And typically at that level, it's going to be read the specifications I've just created to know what I'm building, build it, and then test that it works correctly, repeat it over and over again. And once you have that in place, then your actual builds are going to be things that can fit in the context window to go and implement the tasks, leverage the agents that you built so you're not consuming too much context. Because they're small chunks, it's not going to run for too long before you get a chance to go and check what changed, did this work, do some course correction. But my involvement in that kind of workflow, it tends to be things like manual testing, getting the agent to create documentation or update documentation about what it's built. And that's what these workflow tools can help with. Typically what you end up with as a result of using these tools is a set of documents which give you the specification, the technical documentation for your project. And they are constantly producing sort of incremental change documentation. And the better ones take that incremental documentation and then go through a sort of a closing up process where they'll update the main body of documentation and then archive the change. I think if you try and sort of manually manage this process, you can get away with it for quick spike projects, short-lived things. But very quickly, you end up with outdated documentation littered throughout your project, and that can be too much information, especially when it's out of date or wrong. Will send your AI off in the wrong documentation. So having discipline and a process to keep your technical documentation accurate and up to date is very important. And you know what? That's actually one of the most valuable uses of AI we've had sort of early on in my experience, is finally being able to keep the project documentation in repositories up to date.
Yes.
It's super easy to say to the AI, create some documentation for this project, and then read all the documentation that's there and check that it's accurate. So I'll shout out one workflow process,
Okay.
OpenSpec. OpenSpec is one that I really like.
I love that.
Yeah. So yeah, highly recommend looking at that one. Yeah, very, very nice flow. Kind of works how I said, and you'll end up with a nice history of what you've done within your system. But even then, I mean, OpenSpec is very fine grained. It creates very formal specifications for your requirements. It kind of reads like user stories. So this is sort of the must should have. So it's very sort of precise, sort of engineered requirements. I think it's helpful to have a layer above that where you're maintaining what is this project for? What is the rough architecture? What does the architecture look like at a high level? The kind of the documentation that you'd want to give to a developer that you're onboarding to a project, for example. That's not what you're going to get from the artifacts that OpenSpec produces directly. They'll be too sort of fine grained. So there is a layer above that where you're sort of managing the bigger picture as well.
Okay. You mentioned also tests. What from a new project, what do you just assume? What's the baseline of tests that you want to see?
So, I mean, this is something that I've been experimenting with a fair bit. I spent a little bit of time going down the rabbit hole trying to engineer a workflow that was doing a very, very tight TDD experience. So, I think it's important in any project that you have good test coverage, especially one where you're handing off a lot of the work to AI, because that's one of the sort of the best safety nets that you can have. However, I think the way that AI writes code with, in some ways AI is, got a bit of catching up to do to get up with humans. But one thing that it doesn't have to catch up on, that it's already way ahead of us on, is the ability to track many things in front of mind. That context window, small as it is, can think about or have in memory like 100, 200 things at once in a way that we can't. So the process of write a test, implement it, check the test, right, that red-green refactor cycle, I found is quite expensive with AI. So I tend to get down to that grain that OpenSpec sort of, if you use it well, will leave you at, where you can carry out a handful of tasks or a sort of unit of functionality that may end up getting covered by somewhere in the region of between like 10 and 30 tests maybe. Is sort of a sweet spot where it's fine to say, do that functionality and make sure it's covered with tests. And then go through, have a code reviewer agent to go through and check that the tests actually match the specifications. So they're actually really testing that the specifications are met and that the code passes the tests. And then on top of that, use code coverage. Code coverage is crucial. So it's very easy for the AI to produce a very convincing set of tests that all pass, but it's missed hitting critical functionality. So, for example, in the .NET world, then I'll be using typically something like XUnit and running code coverage reports, and I have my test agent that will read the code coverage reports and and check that we've got good coverage. And the way it's doing that is not necessarily saying, do I have 100% code coverage? Because there are lots of places where 100% code coverage isn't practical.
Mm-hmm.
So, for example, there are some kinds of user interface which are very hard to get good test coverage on in a unit test tool. You'd want to save those more for your sort of playwright level integration testing. So there'll be known areas where you don't want coverage. But what you can do in these evaluations is to say, look at the code that just changed. So have the agent can go look at Git and see what's changed. And then it can target that specifically when it's analyzing for code coverage. So you get that focused code coverage report. And then on top of code coverage as well, I'm quite a big fan of mutation testing as well. So code coverage is very good at telling you what lines of code got covered. It's not so good at working out, did all of the different potential branches through the code get covered? And that's where mutation testing really shines. So Striker is a good example of a tool that does this. It covers, it certainly does .NET. I think it does JavaScript as well, I think, and possibly one other. But so what mutation testing will do is literally reach in and change bits of your implementation. You'll change an equals to a greater than, various sorts of branching, and it's looking to see, when I made that change, did a test fail? And if no test fails,
it's not
when you
covered.
Make that change, it hasn't covered that particular eventuality. So again, that comes with a little bit more cost. It takes a little bit more time to run. So if you have these sort of chunks of implementation that you're building, then you can sort of have your implementer, you can instruct it to make sure that it's writing tests, that the tests individually pass. And then when you get to the end of the unit of functionality, you can have that bigger sweep, that more intensive review process where you're saying, now go check all the coverage, do the mutation testing, and feed that back. And my review agent will give me a sort of a structured report where I'm looking for things that matter to me, again, tailored to the specific project, right? Because it's not, I don't think it's particularly helpful to go check that everything is secure, right? Because that can mean many different things, and there are going to be some things that will be far more important than others. So the more targeted context and instructions that you can give, the better. And these are things that will constantly evolve as your project grows. So you need to build in, kind of like you did it, you do a sprint review at the end of Agile. You need to have that in your process as well to say, are the right things in memory? Are the agents that I wrote have they still got all the right instructions in them? Maybe you were building .NET when you started, but then you decided you need a front end and you wanted to build that in React. Have you paid the same amount of care and attention to the tooling dealing with the React code as you did when you set the project up and you did .NET?
And I see a theme that I hear you espousing, which is make sure that the small pieces are done really, really well, and then build on, and then build on, then build on, as opposed to just, like you mentioned, check to make sure it's secure from a big outside in. That if you build and layer and build and layer and build and layer, you like that outcome better.
Yeah, and those bigger checkpoints, they don't have to be, if you've got your agents tuned right. Sometimes it can be, it's time to take a step back and do a different kind of review of the project. So I had an experience recently where I was building out a web UX that was pretty intricate. It had being able to support keyboard and a mouse and switch between them was very important.
Mm-hmm.
So we were doing things like tabbing around the user interface, arrowing around the user interface, and this had been put into the specifications gradually, like, I need to be able to use the arrow keys here. I need to be able to focus on this. And when I move the mouse, the focus should move to whatever the mouse is over. And if I start using the keys, I should be able to navigate the focus away, even though it's really kind of complex and intricate UX requirements. But the challenge was that because that was specified gradually, the implementation had not been done with sort of the whole system in mind. Mm-hmm. So there were little pockets of code in different components throughout the front end to deal with that. And so that started to emerge as it's sort of taking longer to solve those little bugs and get consistency through the UI. And that's where, we're leaning on sort of years of experience to sort of smell there's something not quite right here. We need to take a step back and think, well, actually, have we thought about putting in a proper state machine to control the interaction model of this application? Right? And this is the kind of moment where I think, you know what? I've still got a job here for a long time to come. To be able to see those kind of signs where actually what's really required at this point is a significant refactoring of the approach, because it's going to, you do that and it's going to accelerate development going forwards and keep it easy to maintain the system. Those are really important things. And you can get the AI, you can literally go like review this code base and see if there's anything wrong with it. But I think you have mixed results if you do that.
Yeah.
It's useful to do because you can find things that way. But if you notice something that's going to affect how efficiently the AI is writing the code, then go in and do the spring clean and stop and have a conversation with the AI, as we did here. Like I was able to, in that particular instance, to say, I think a rich state machine interaction model would work well here. What could that look like? And then you're getting meta again. Get it to help you make the plan to help it be better.
So as we kind of get to the end of our time here, I have 2 remaining questions for you. One is, it sounds like you're having AI a lot of the actual coding. And so the question is, how much have you or your projects sped up or changed your overall throughput, and how do you know? How do you measure?
So there are some, the data is always king, right? So, there are some very practical examples. So one of the things that comes upon us every couple of years in the .NET ecosystem is that the .NET framework updates. So, we have some very hard figures that show how long it took us to upgrade our systems from .NET 6 to .NET 8. And when it's come around to doing that for .NET 10, we've done it with agents. So we can see quite starkly that it took a significant fraction of the developer resource to do that work. Mm-hmm. And it took significantly less time than it took previously. So I think, that's, you're fortunate enough there to have a like-for-like comparison. Some of it does come down, I think, to sort of a common sense intuition. But obviously, the more that you can put data on it, the better. So you can look at things like bug counts going through your system, reporting problems, and you can look at metrics like lines of code read. I don't think they're quite so useful. I prefer to sort of look at functionality, tickets, functionality getting closed off. But if you use your project management system, whatever that is, to try and get the numbers, that's going to help you. I think one of the things I've seen, though, is that we're even taking on projects that we wouldn't have thought to take on before, because you'd have looked at something and said, you know what, that's just going to be too much. That's going to be too much work. I'm not even going, we can't even consider that right now. Whereas today you can say to an agent, this is what I'm looking at achieving. Can you go map out a plan and even have a stab at it for me? An AI is not going to get offended if you throw it in the bin, right? If you bonk it on the head and say that's rubbish. One of the secrets to success in the hackathon experiences that I have is that we would create a team of agents, give them a whole bunch of work trees, and say, create a cool UX and with this, and this, right? And then have like 10 different agents doing that, and then we just pick the best one and throw the rest in the bin.
Mm-hmm. Yep.
Or mix and match the ideas. So you can very cheaply experiment to see in a way that you never could before. This isn't speeding up what would have done before. It's enabling you to achieve entirely new things that you'd never have even considered doing before. So that's another aspect of it as well.
Awesome. So you're pushing ahead and you're leading in your organization and you're teaching. Where can our listeners go to learn more from you?
From me personally.
Or where would you direct them to learn more about this topic?
I would always lean on a good piece of advice that I've always given out in the past, and that is it always pays to read the manual. It's surprising to me how much people can be using a tool or a service, anything, and they've not actually literally gone and read the instructions. And that's doubly important in this space because those instructions, those guides do get updated all the time. I'll give you one particular example, right? You should absolutely know, if you use Claude Code, you should know the difference between skills, commands, agents, how to manage the plugins, just the mechanics of how those things work and how impact they have on context. The instructions are actually pretty good. The problem is they change quite a lot. So, there's a lot of really bad and outdated information on the internet. So going to the source as much as possible is really helpful. I'll give you an explicit example. So /commands and skills in Claude are essentially now one and the same thing. but there are still any number of guides out there that will tell you when to use slash commands and when to use skills.
Okay.
It's just a cognitive mess in your brain, right? You
Aren't
don't
they
need
all
to keep
now?
worrying about that.
Aren't they now all just helper prompts?
Yeah. Well, there you go. I mean, like every tool has its own domain terminology. So I think skills have pretty much been standardized now largely across the tools. But even Claude, right, it still has things that sit outside the specification that are particular to Claude code that can be really nice to have. But it used to be that you'd write a command if you wanted to press / and see it in the CLI. But now skills just do that anyway.
Yeah.
A skill can be automatically sort of discovered from its front matter and used when the AI decides it's appropriate. But it can also be directly invoked as well. So you don't need to worry about the distinction anymore.
I'll make sure everything we talked about, we'll put that in the show notes. And man, I could visit with you for another hour on this. But thanks so much for coming on the show. I really appreciate it and kind of giving your perspective and experience applying AI to your software organization. I appreciate it. Thanks so much.
Thanks, Jeffrey. Great talking to you.
Oh, my pleasure. My pleasure. And until next time, dear listener, keep chipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.